Alright, in this video what we're going to be doing is setting up the foundational classes, some base classes in a shared library that will be used by the other microservices that we're going to build. So right out of the gates you might be wondering, one of the main points of microservices is that you should be able to edit, change, and scale microservices independent of any other microservice. So a change in one microservice should not necessarily mean that the other microservices need to go off and immediately update themselves. We're going to talk about different ways to do that. You want to make sure that whenever you make changes to your microservice that they are backward compatible with existing APIs that you may have exposed that others may rely on. Same thing with the events that you might be passing around. But one of the other things here is I just said we're going to create a shared library, or DLL, that the microservices are all going to rely on. And in general, you don't want to be doing that. You don't want DLLs that are shared across multiple microservices, because at that point you're coupling those microservices together. And now if one microservice does require some sort of change or update within the shared DLL, it could force the other microservice to have to be updated at the same time, which is one of the main principles of microservices that you're breaking at that point. However, there are base classes that are extremely helpful for some domain-driven development concepts around aggregate roots, entities, domain events, things like that, that should be very, very stable. That once you create these shared base classes, that you should in reality not ever really have to come back to them and edit them. That's why I personally feel it's okay to take the components that we're going to be building in this video, put them into a shared DLL, and let the microservices reference them, because it's not intended to change. You'll see other development shops that actually take what I'm about to show you and repeat and copy and paste this code in every single microservice. I just have a preference, but I'll leave the choice obviously up to you. And one of the main takeaways here is also just about the base classes and their purposes as well. So let's get into it. We're going to create a class library here. And you'll see what I've got in the folder structure here for where I'm going to be putting this is we're building out this shopping application, and there's going to be a back end and a front end. The back end will consist of multiple microservices. Each will be under their own folder, and then these shared DLLs I'm just going to keep under a folder called shared. And our first library that we're actually going to be creating here is going to be referenced from the domain layer of our application. So as we're building out our microservices, each microservice will be a layered approach, where typically you're going to have an entry point of some kind, an API layer, then a business layer, and an infrastructure layer. If you're not familiar with it, my coding style tends to align with clean code architecture. So if you're not familiar with it, I highly recommend you do some reading about the clean code architecture. I'm a big fan of it. I think it leads to some really clean, elegant code. And what we're going to start with here is the domain layer for our shared library here. So we're just going to say shared domain is our shared DLL. Going to go ahead and create our project here, and we can delete the initial class they gave us, and we're going to create a new folder that is going to be called DDD, short for domain driven development design. And we're going to create our first class here. So we're going to basically create classes for the different components that we're going to continually be making that structurally make up each domain, such as aggregate roots, entities, value objects. First one we're going to create here as a base class is our entity class. And as we learned, the entity class, what defines an entity class in domain-driven development is the fact that it's addressable by its ID. So its identity is controlled by an ID, not the values of its properties, but by the ID that is assigned to the entity. So you can determine whether or not two entities are equal simply by comparing their ID properties. So we're going to have a public abstract class, because this is meant to be a base class and not directly instantiated. And one of the first things we need is a ID. I prefer to use GUIDs as the IDs. And one thing that I've done here is I've used a property with a get and a set, but you note that the set is private. And you're going to see that very consistently throughout the base classes that we're going to build, but also the domain objects and other entities that we're going to create on top of these base classes, that the setters will be private. The reason for that is I'm a big fan of the principle that you really shouldn't allow code external to your class to alter state by directly calling setters. They should be using methods or constructors or factories to alter the state within the object. Anytime external code interacts with the object, you really want to make sure that they can't leave it in a state that is invalid. So one way to control that is to not allow them to use setters to either intentionally or unintentionally set different property values on the object that ends up leaving it in an invalid state. The other reason for not wanting to expose public setters is oftentimes some sort of change to a domain object, some sort of business reason for changing it, is much better described with a function name. So the function can describe like what type of change is being made to the object, take only the values it needs to perform that type of edit, and it becomes a much more descriptive transaction via the method name and the parameters passed to the method name as to what purpose that function serves and how it's going to alter the state of the object and what business logic is being implemented. So you're going to see that very consistently throughout, and I'll continue to try to iterate on why I think that's such an important concept. But the next thing we're going to do is we're going to add our constructors here. So we want a constructor where the external code might be passing us a GUID, and then we're also going to have a constructor where the external code is not passing us the ID, and therefore we are going to generate one internally. One of the other concepts we're going to see in the base classes here across the different base classes that we're going to create is we want to override our hash functions, our equal functions, to compare two objects, and also in several cases the toString operator as well. So what we're going to do here is do a requested hash code. In fact, let me just shorten that down to hash code. Hash code is something we're going to compute, and each time the external code is referencing or asking for the hash code, we don't want it to recompute it if we've already computed it once. Hence, we want a private property internal, where now we're going to override our get hash function. And the first thing we're going to do is see if we've already computed it. So we can say if the hash code has a value, or sorry, if it does not have a value, then we want to compute it. Otherwise, we can just return our hashcode.value. So again, if we've already computed it, we can simply return it. Otherwise, what we want to do is actually compute it here. And we can do this, although a recommendation that I found in Microsoft's implementations of domain-driven classes is that you also XOR the value so that you're actually distributing the ID, the hash value, at least a better distribution of the hash value itself. So I can include some information on where you can read up more on that, but this is our hash function for our object. And now what we want to do is tackle the equal. So if we want to be able to compare two entities to determine if they are actually equal, we're going to override this method here. And first thing we need to do is basically see if the object we've been passed is null. So if it is null, or if the object itself that we've been passed is not even an entity, we can immediately return false. We know that there's no equality. Otherwise, what we can do is we can say our entity if we cast it and then return whether or not the IDs match, because again what we've said here is for in the domain-driven world, entities are equal if their IDs are equal. So that's how we override our equals method. we also want to override the equals operator, just for simplicity's sake, so we don't have to use the equals method. We can actually use the equals operator as well, but we want that to reference our equals method call. So what we're going to do here is override the equals operator, and what we can simply return is whether left equals right. And then we want to do the same thing. In fact, the compiler is complaining with that red squiggly because we have not overridden the not equals. Look at that, IntelliSense did a great job of figuring out exactly what I needed, which is we're going to do the same method just with the not operator in front of it. So now we've overridden our operator as well, and so now we'll override our toString. What I like to do for the toString, which helps in debugging and things like that, is simply return the ID value. Alright, and then one last thing that we're going to add here to our entity class is a collection of domain events. So what we want to be able to track with the entity is a set of domain events that have been issued by entities. So barring further examples, we're going to get into a lot of examples where we're going to see this get used. So just take it for the moment that we're going to need this collection to keep track of domain events that are being issued by the entity, and then we'll eventually see examples of an entity issuing domain events, and then we'll also see how this collection gets used so that, once the domain event is issued, how we actually call any listeners that are listening for that particular domain event. But for now, let's just concentrate on adding the ability to track the domain events within our entity here. So we're going to have a private read-only list of domain event. Now, we haven't defined our domain event class, so it's going to be mad at us for the moment. So there's our collection. Now, what we can do is we can expose that, but we don't want to expose it in a way that anybody could directly alter the list itself. Again, similar to the getters and setters conversation about, we want people to come through methods when they're looking to add or change a list in some way. We want them to use methods and not actually have direct access to change the list itself. So what I typically do is we expose it as a read-only list with, again, we don't have our domain event there just yet. Where we're going to explain that as a collection of domain events. And there, so we've exposed it in a read-only fashion, so there's going to be no add and remove methods. But we want to offer the methods through which they can actually perform the addition of a domain event. And we also want to expose the removal. Alright, so we got our add and remove. And that's it for our entity class. So again, it's really just around setting the fact that we're going to have an ID property on all of our entities. The ID is what makes which makes up the identity of an entity, and therefore you can determine equality by checking the IDs, and then we're going to have this domain event collection inside. So the next thing we want to create here is our domain event class. Let's knock that out. Again, public abstract class. And alright, so for the domain event, we do want an ID on this as well, so that every domain event has an ID that we can reference. I'm going to use a shortcut here. We're going to basically set that ID in the constructor. So we'll just cheat and do it this way, so we don't have to have a constructor itself. All right, so that's it for the domain event. The abstract class itself doesn't have a whole lot to it. The domain events are basically DTOs in my mind. They're data transfer objects, so they just have a bunch of attributes and properties about the data that is relevant for the event that has occurred. And then any sort of domain event that we're going to launch is going to inherit from this class, and the name of the class will tell us what type of event occurred. So we got our domain event, which should now make our compiler here much happier on our entity. So the next thing that we can do is we can declare our aggregate root base class. Public abstract, as we've been doing. And we're actually going to inherit from entity, because an aggregate root has all of the same properties as an entity. It will internally have domain events. It will have an ID. So what makes it different, as we learned about in domain-driven development, is that the aggregate roots are what get stored into and come out of the persistence layer via the repository. So you cannot directly store or retrieve entities, but aggregate roots you can. And when an aggregate root is pulled out of the repository, and we'll see this when we go to implement our repository classes, when we pull the aggregate root out, we're pulling him and all of his structure, so all of his child entities as well. So the whole thing is the whole aggregate root moves in and out of persistence together. There's no lazy loading of properties, no lazy loading of entities when we're doing that persistence. So the one thing that I also like to do, and here I'm just going to cheat and copy and paste some code in, is add some audit trail sort of properties that we're tracking. This way we can keep track of the date created, last updated, created by ID, last updated by ID, and you'll note that the last updated by properties have a nullability to them. The reason being that when the object's first created, my tendency is to set the last updated to null to indicate that this object has been created but has never been updated. And then after the first update occurs, we would finally populate the last updated by, and if it gets updated a second time, we would update them again. Date created by would never change after the initial setting of those values. So we also need some constructors that are going to basically call into the base class, which is the entity class. And if you recall, in our entity class we had two constructors, one where we pass an ID, one where we don't. And actually, for consistency purposes, I believe in the entity we had it, the first constructor being where we are passing an ID, so I just wanted to rearrange these to match. And then we need a process by which we're actually going to be able to set these fields. So again, you'll notice, and actually these should be private, sorry. We don't even need protected. What we're going to be doing is offering up two methods for setting the creation values and then setting the updated. Let's call this last updated to be more accurate, sorry. No, I'm actually going to go with what I originally had here, sorry. Set creation and set updated audit fields makes more sense, I think, to me. But this is our aggregate root, so it doesn't have to layer on a whole bunch of extra properties or values relative to the entity. It gets a lot of its behavior from the entity. But the other major distinguishing factor, and we're going to see this when we go to build out our repositories, as I mentioned, is these are the things that can move in and out of through repositories. Entities cannot. So that's another distinguishing factor of how this class will be used. So we've got our aggregate root, our domain event, our entity. There's two other classes that we want to add for the moment. We want to add our value object class. So a value object is different than an entity in that it does not have an ID, and it's the values of its properties that determine its identity, and therefore equality would be comparing the different attributes between two objects. So if you had two value objects and you wanted to know if they were the same, you're not going to be comparing IDs, you're going to be comparing their properties. And also the important thing about a value object, just to repeat it, from the domain-driven world, it is immutable. So once you create a value object, you cannot change its properties. You must recreate the whole value object if you need to change some sort of property on it. So we'll see examples of that, and we'll get more into that when we get to those pieces. But let's go ahead and implement this guy. So we're going to be overriding basically for our equality operators and for our get hash functions again. So first thing we're going to do is public override our boolean of equals. So to determine equality, we're going to say if the object is null, or the object is not equal to the same type as what we actually are comparing to, we can just simply return false. Otherwise, we are going to say value object. We're going to cast our value object. And then we got to determine equality. Now again, we don't have an ID that we're going to return it on. We want to determine equality by the different properties. So what we're going to have is a method that all the value objects must implement to define the properties and return the values of the properties from a comparison point of view of all the properties that make up the value object that should be compared when determining equality. So we're going to have a get equality components method, which we'll implement in a second here, where we're basically going to take and compare to the other object, calling the same method on the object we're comparing to. So why don't we add here oops. So there's our equality. We're going to see examples of this when we actually go to implement some value objects. We're going to have a bunch of them. So this method, we'll see how it gets implemented and returns values for comparison purposes when we start to implement a few examples. The other thing we want to do is we want to override, like we did in the other cases, our operators for convenience purposes. So we can do static boolean operator. We're going to have a value object left and right where we can simply return that. And we also want the same thing for not equals. Where we're going to return the same thing, left equals right, where we're going to use our definition of the equals function. But in this case, we're just going to not it. And then finally, we want to implement the override for our hash code. And that's going to be return, oops, int, my apologies. We're going to return the, we're again going to use our equality components to basically select values from each and then aggregate oh my bad, hold on. Now we can aggregate. We're going to aggregate the hash values like so. So we're going to again, rely on our get equality components because it's really the ID of the object that we should be hashing. And in the case of a value object, the ID is the values of the attributes that make up the value object. And so we're going to loop over each of them. If we run into a null, we'll use a 0. Otherwise, we're just going to hash the value itself. And then we need to aggregate across all of those hashes of the different properties. And that's our value object. Last class we're going to create here is an enumeration class. So C#, like many other languages, has the construct of a enum, but I prefer to implement my own here. So with the constructs that are in the languages, you are limited on, when you go to name your enum, you can't have spaces. There's other types of restrictions, and if I want to be able to take this enum, pass it to the front end, and say, here, display this in a drop down, I really want to be able to control the spacing and how it's going to look on the front end, and the enum concepts don't necessarily lend themselves to that as easily. So I prefer to wire up another abstract class here called enumeration. It's going to behave just like an enum, so we're going to end up having two public properties, one being an integer ID, and again we're going to have a private setter, and we're going to have a name property, which is string, which is also going to be a private setter, and then we need a constructor, which is going to be protected, and we'll see why when we actually go to implement some of these, why a protected versus a public constructor, where we basically just want to take the name and the value coming in the constructor method and set the properties. So just like our other objects, we're going to want to override the equals. So public override boolean equals, and probably starting to look pretty similar to all the other objects where we've implemented this. We just want to check if the incoming object is null. We also want to check if the type of the current object we have is the same as the incoming. And if it is not, we want to return false. Then otherwise, we can compare the IDs that we have, and we know that we have the object is of type enumeration at this point because of our if check above. And we can simply return whether the IDs are equal. And then just to save some keystrokes here, and boredom on your part, I'm just going to copy and paste over our override that we also implemented in a couple of other classes for overriding the operator for equals and not equals. And then we have to implement our hash method here. So override and return. We're just going to take the ID and end up hashing that. So actually, I'm going to take from our entity as well, because we want to compute it only one time if it's going to be called multiple times. So we again can borrow this concept of, okay, if the hash value, we've already computed it, we can just return it. Otherwise, we're going to compute it by taking the ID property, getting the hash of that, and then using the XOR operator to spread the values out a bit more in a distribution. Okay, there's one other method we're going to add here, which we'll see the purpose of a bit more when we get into some actual implementations of this. So while we're here, we're going to implement a method that's going to return an enumerable set of the values or the different entries that are in the enum. So T is going to be an enumeration. And the point of this method is going to be to, like I said, return all the different values that make up the enum. Which does actually have a lot of good purposes. So what we need to do is we're gonna use some reflection code here. So we're gonna need some binding flags. We're gonna say we want the public. Whoops. public. There we go. We're also going to see when we go to implement these, when we go to implement the values that make up the enumeration, those are going to be static properties on the class itself. So we want static, and we want declared only. And then what we're going to do with those, though, is we're going to say select. Use our good friend link. So we're gonna basically get the properties, if you're familiar with reflection, off the object or the type itself. You gotta actually say what object you want to get it from. Well, because these are static properties, we can just pass null, and this will return a list of all the entries that are actually in the enum. This can be helpful when we want to get a list of all the enum entries and then pass that back to the front end for display purposes and a drop down and things like that. So that's it for this video. We've set the foundation for our domain layer of our classes, and so in the upcoming videos, we're going to actually look at starting to implement some of some actual domain layers for one of our first microservices, and we're going to end up leveraging these classes. So shameless plug. Feel free to reach out to me at Keystone Code. So that's my LLC. So feel free to email me at dmichael@keystonecode.com or visit the website. Also do trainings for different organizations and development teams. So if you're finding the videos helpful, think you might want some more one-on-one training, please don't hesitate to reach out. Thanks.